Let's go to space.
Okay, go ahead and get started here, and I'll try to watch the screen here for people joining. I know sometimes people come in late and then they can't get in, and that's my fault because I'm a one-man show here trying to manage all of this. And if you come into the waiting room and I don't catch you, then you don't get in, or at least not until I look over here at the comments and start adding people. So my name is Tim Alatorre. I'm Chief Operating Officer of Orbital Assembly Corporation, and welcome everybody to Fridays with Tim. Today is December 3rd, 2021, and a lot has happened. I say that every week, but think things are moving. And we sent out in the invite earlier today for this call a press release that we sent out this morning regarding the NASA CLD proposal, as well as an email that I had sent out to our team upon hearing the news. So for those of you who are watching this later or who didn't see the email, essentially the press release was stating that yes, Orbital Assembly did in fact submit a proposal to NASA for their commercial LEO destinations. It wasn't really a full solicitation, it was more of a proposal request. And we got the results. They announced the winners yesterday. The three companies that were selected were Blue Origin, NanoRacks, and Northrop Grumman Systems Corporation. And while Orbital Assembly Corporation didn't receive an award, we did get some feedback from the folks over there at NASA Johnson who had reviewed our proposal. And in the email that I sent out, we highlighted a couple of the things that they had stated regarding our proposal on the positive side. And just to kind of go down the list here, some of the significant strengths included a flight demonstration of automated on-orbit assembly of truss, which is our gravity ring PSTAR mission coming up in 2023, which you see behind me. Also, they liked that we had more than 2 crew members at initial operations. So our initial plans for Pioneer would allow for up to 7 crew members at that first phase of operation. They also liked our modularity to increase flexibility and growth potential. And they like that we were able to provide the capacity for larger payloads. In fact, let me pull up behind me here real quick, our Pioneer station, just so you can see the graphic. This is what we had submitted to NASA. So they liked that we had capability for larger payloads. Also that we had the potential for artificial gravity and the potential for external payloads. That was one of the things we discussed and proposed to them was on our truss and outside of the couplings and the modules, we could host external scientific payloads. And then they liked that could benefit future technology development and that we had crew on station for maintenance. And they were impressed by our strong emergency response and redundancy planning, which is something that has been a hallmark of all of our designs from the beginning, is those emergency conditions and how to deal with them. And so with that, let's see, there was the first couple questions how to do with this, which is a great segue into this. So Keith, glad to have you back here, Keith. So Keith was asking, what were the negatives and weaknesses raised by NASA in their response to your proposal? Well, first off, one of the negatives I think was a misreading of our proposal. They were asking how would we dock to the station in rotation, and that was not something we were planning on doing. The station is to be despun, and docking would occur in a non-rotating position. The other part they were concerned about was unproven technology regarding rotation. And we did in our roadmap, we have the steps of doing the gravity mission to prove out capabilities for controlling rotating structures on orbit. But they were concerned that wasn't something that had been done before, and that was a negative. So those were really the primary negatives on the technology side of things. The other negatives, there's 2 categories that they rated all the projects on. One was technology, and the other one had to do with the business case. The second one is they felt that our commercial or customer base wasn't as robust compared to some of the other proposals that came in. I guess some of the other applicants had more customers already lined up, as well as because of the technology potential risks doing artificial gravity, and our company is relatively new. they're concerned that without having a large, well-funded organization behind us, that those technology barriers could result in increased project risk, right? And so if you look at the three proposals that were accepted, Blue Origin, they made their big announcement in Dubai a few weeks ago for their orbital reef project, which is gotten a lot of media attention. And then NanoRacks and Northrop Grumman, their station designs have been floating around there on the media as well. All three of those are essentially copycats of ISS. And so, when I'm looking at the selection, what was done by NASA with these awards, they're really trying to pick something that looks very safe. And we knew going in that providing something with artificial gravity was, a step beyond what NASA is comfortable with on their I'm trying to choose my words carefully because I know NASA people will eventually hear what I say. We have a lot of friends at NASA, but there's a lot of resistance to artificial gravity concepts in a big section of NASA. And so we knew that going in. Last year, I think it was last year, there was another proposal request that NASA had for the next step solicitation, and that specifically was for funding construction of artificial gravity space stations. This current award, the CLD, was just to provide funds for the development, for the design work, not actually for hardware. I should mention that the award amounts, the 125 million to 160 million that were awarded for development, our development costs are not going to be anywhere near that. that's a big chunk of change they were giving out for development. But the proposal request that went out earlier last year, it actually never was officially released. It was always in draft form, but that was for their next step program. And that one did not make any mention of artificial gravity at all in those solicitation documents. And one thing that we sent back to NASA was, would you consider artificial gravity platforms? And that program never went anywhere. They ended up canceling the funding for that, and they switched gears to this CLD proposal. And we feel it's a huge win because in this proposal, they actually mentioned as a stretch goal the option for artificial gravity. So I feel like we're making some headway within the NASA ecosystem, that at least they're willing to talk about artificial gravity now. And in our solicitation response, they even, they mentioned that one of the strengths was an artificial gravity proposal. So while there's still, NASA's still viewing that as a significant technological risk, the fact that they're also seeing that as a strength and something that they're mentioning in their documents, we feel is a significant change and very encouraging. So Keith, that was a really long answer, but I appreciate you getting your question in there first, because that kind of tied in right with what I was talking about in my introduction today. And then Chuck asked a question about our former CEO, and that question seems to come up quite a bit. We, because we have been involved with mediation regarding our former CEO's exit for so long, we were unable to make a formal statement regarding it. And Rhonda Stevenson has been our CEO in place since April. And the former CEO continues to be a shareholder with the company, but his exit was not in regards to our current design. Actually, Pioneer Station, this design was conceived, designed, and completely developed after his exit in April. So this current design did not play a part in that. Let's see, Kyle Sims. Never been so happy to be a part of a crowd. Well, thanks, Kyle. Glad to have you. Let's see, we got a few more people in the waiting room. Welcome everybody in the waiting room. Sorry, I just saw you. Let's see, Carly's asking about Zoom. Yeah, if you're having technical problems, I'm sorry, I can't provide tech support on this. Maybe somebody in chat can reach out to Carly, but we will be posting this on YouTube later, and you can watch the whole thing there. Let's see, Joe's asking, I've seen the video that demonstrates the scaffolding being made into a circle in space. It says the robot does this with reconstructed materials. how do these materials enter the robot out in space, and how is there some sort of hookup, or is the robot launched with some materials installed? So let me change my background here. We'll go back to the graphic of the gravity ring. I'll see if I can't point it out here. So gravity ring's behind me here, and you can see the PSTAR. There's my finger. PSTAR's down here at the bottom. So this image here is just the structure. None of the propulsion systems, photovoltaics, radiators, or other mechanisms and motors are on this scaffolding. This model is not complete yet. But the PSTAR, for anybody who saw the video or was in person for our DSTAR event earlier this year, the PSTAR is very similar to that. So the PSTAR is going to launch with the different structural members for the truss in what we call magazines. So the DSTAR had two L-frame magazines and a T-frame magazine. So those are longitudinal frames and transverse frames, which is where those terms come from. And the PSTAR will be very similar to that. So the PSTAR actually, in order to get it to fit into a fairing, we actually have 4 L-frame magazines and 1 T-frame magazine. But all of those structural frames will be launched in the PSTAR. The PSTAR does a little transformer action, and if you see the videos out there, you can kind of see here. There's these 2 narrow L-frame magazines. They fold up and they join into one larger L-frame magazine on either side, and then all the frame sections roll into the assembly portion of the PSTAR, and they're all joined together. So if you look back at our DSTAR event, the ground demonstrator of our hardware earlier this year, there were a lot of rollers and mechanisms that moved everything around. That's very similar to what's going to happen on PSTAR. Of course, PSTAR is going to be operating in LEO, in orbit, in a vacuum, and so all the the mechanics and the motors are all rated for vacuum operation, and we don't have gravity, which is a plus as well. And so that simplifies to a certain amount how we move things through the PSTAR. And then the PSTAR will join all of the frame sections together, attach the propulsion, photovoltaics, radiators, and then it gets spit out the other side. So it's a little factory floor that we're launching with the PSTAR. Everything is put together there, and then the truss comes out and then comes back around and meets on the backside. And then if you see that in some of the videos, and I know with our live event that we did a couple weeks ago with the whole team, at the beginning and the end, there was some video of PSTAR operating in the background. And if you look at that, the top of the PSTAR opens up and then detaches from the gravity ring when construction is complete, and then it'll go off and do its next thing. So that's kind of how that works. And then let's see here. Yeah, I'm sorry if you're not receiving the emails. I guess check your spam folder. Carly, congratulations on getting your audio working. Glad to have you. Yeah, Nar's asking about, it's puzzling that no one else thinks the gravity solution is important, and why. I don't think that's entirely the case. I think Jeff Greenblatt and I, our CVO and myself, we were involved last month with a NASA NIAC workshop. They brought in 70 experts in different fields to come together in a room and figure out what large-scale space communities would look like and how do we build them. So it was a room full of geneticists and engineers and economists and ethics specialists and lawyers and kind of the whole gamut, architects, you name it. And Jeff and I were actually brought in as experts on the engineering side of it to consult on the methodology and structures that would be required for constructing large space habitats. So the whole conversation in that entire workshop had to do with gravity structures. I think everybody that's developing concepts for moving humanity off planet recognize that a certain amount of gravity is required. I think the holdup within maybe the larger NASA ecosystem has to do with risk management and risk aversion, right? NASA funding has been precariously, it's always balanced between being cut next day, right? just like that, the program that was in place before, the Next Step program, that was defunded by Congress. And so I think what with NASA, and I have no idea, I don't, I'm speculating here. I don't have any insider knowledge with NASA's decision-making process other than, some conversations I've had with NASA people, completely off the record, nothing official. But what I think's going on is NASA had some funds and they were trying to get them into the public sector as quickly as possible and create bets that were safe enough that they could get some easy wins, right? And that's why I think they weren't funding hardware, they're just funding development work, because it's really hard to say, oh, the development didn't pay off. And then they've also, funded companies that already have significant funding. Blue Origin is not hurting for money, right? And so that also further hedges their bets where, they knew they couldn't fund these programs enough to actually get them off the ground and flying. And so I think that's what's going on there. I think the need for gravity is well understood. It's just, who's going to take the risk and actually get it done. Now, in our internal conversations and what we've been working on with orbital assembly, we actually don't think the risk is that great. We've identified a lot of the different issues and problems. Like NASA in their response, they were talking about some of these control issues, and we've done the math, and we think it's actually fairly straightforward. So we're going to be doing gravity. We're going to prove to the world that you can spin up an object and control it, and the world won't end. so that's where we're at with that. And yeah, Chuck, I agree. Artificial gravity is definitely 30 years overdue. Aiden, I didn't want to pass you up. I see your hands raised there. Why don't you go ahead and unmute, and we'll make your video big here, and you go ahead and ask a question.
Hello. Yeah, will there be any major differences between the STAR and the PSTAR?
So STAR. So that's a good question, because I think we've changed our terminology a little bit over the years. STAR used to refer to kind of the final product, and we had some incremental phases where we had the D star, which was our demonstrator, and then we had originally PSTAR was called the prototype star, and then we went to the STAR. But what we realized was that the STAR platform really is being purpose built for specific architectures and sizes. So we've renamed the STAR platforms to be PSTAR, which is the Pioneer class star, and then we have the V star, the Voyager class star. Whatever happens after Voyager, that will be, blank class star. And so the PSTAR, the Pioneer class station truss assembly robot, is capable of building trusses with a cross section of up to about 1.6 meters. And then the Voyager star is able to accommodate truss sections up to, I think, 5 meters is where we're at right now. And so that, there are different capabilities, different scales of structures. So the STAR platform, we're now calling our D star that's the very first star. That was the first star we built, and that was designed for 2-meter truss in 1G, right, in a 1 gravity environment. PSTAR is being designed for about a 1.5 meter truss in microgravity. It's theoretically, possible at some point we could have an L star, a lunar star that's building structures on the moon, or for example. It'd be the same sort of methodology potentially, or just a purpose-built robot for construction is how we're terming the terms we're using for that. Let's see. So Carly's saying, I think speaking of artificial gravity, she's saying, I don't think it's an issue that they don't think is important. It's probably more likely that the construction of such a structure in orbit space will be substantially more complex than the regular style of orbital vehicle. Yeah, if you look back at, so I disagree with that premise. I don't think it's more difficult, and I'll explain why. If you look back at ISS, there were 2 main components that were joined on orbit for ISS. The first was the habitat modules, and then the second was the truss that then they mounted all the solar panels and radiators off of. And both of those were assembled by hand. They had, once they had the Canadarm arm in place, they were able to position them. But if you go back and look at that footage, they had astronauts out there doing spacewalks, tightening bolts, right? And so if you look at the truss behind me, if you were to assemble that with extravehicular activity, astronauts in EVA suits out there bolting together all those connections, it would be incredibly expensive and incredibly dangerous. And I think what NASA, well, I shouldn't blanket all of NASA, right? I would say certain people, when they look at what we're doing here, they're not understanding the advances that have happened in telerobotics and some of the capabilities that now exist for on-orbit manufacturing and assembly. So I think that the truss behind me is actually going to be significantly easier to build, and we'll do it considerably faster than the truss that was built for ISS. And we can use smaller launch vehicles with less payload capacity to do it. So that's my take on it. Let's see, Burke Kalberg, and sorry, Burke, I'm probably saying your name wrong. I'm American for the United States. Let's see. He says, thanks for your openness in addressing negatives raised in the NASA response. Yeah, there's really nothing that is worth hiding regarding the negatives. I think any objective observer of what we're doing could probably identify the weaknesses in what we're doing. And like I said in the email to our team, we have work to do, and we know it. And we're fighting a lot of institutional, momentum as well. So we get that. Question from Burke is, how do you plan to design and build the habitat modules? So we are not, the design, let me back up here. So the habitat modules that are shown in the rendering that I had up earlier of Voyager Station, I'm sorry, this is Pioneer Station. These are actually Voyager modules as well. But the modules shown here are rigid modules. So our rigid modules we are designing in-house, and we have been actively meeting with vendors and suppliers, both virtually via Zoom and also in person, going to their facilities for all of the life support and other systems that make a pressurized volume habitable. If you look back at like the early days of spaceflight, if you recall, there was a Skylab, which was basically an Apollo 5 upper stage that they just pressurized and had astronauts living in. You can turn pretty much anything that holds pressure into a livable volume if you have all the life support systems, right? Orbital Assembly Corporation is not going to be building the environmental control and life support systems. There's people that have been doing it for decades and have a lot of flight heritage and have stuff in orbit right now. And so we're going to them for that hardware. So then it comes down to us to design the structure and the pressurized volume and how, all the connections, how does that pressurized volume join to the next section of the station? So all of that we're working on in-house. And really, that's a fairly simple and straightforward engineering problem. The most challenging part is how do you join one module to the next section, right? In this case, in this rendering here, we're showing modules going to access tubes. That design has been modified slightly, but essentially the same problem exists however we join things together. There's a couple of international standards that have been developed that are a great starting point. The International Berthing Adapter, and then there's the International Standard Docking Adapter. And those provide for structural connections as well as power data. They have the capability for gas transmission. Now those standard adapters come into play when we're looking to dock craft. So like the Dream Chasers or a SpaceX Dragon, we want those to be very standard and compliant adapters. And we're actually looking at purchasing those from companies that are already building that hardware. But then the adapters between our modules, we're looking at actually designing those in-house, because then we can, well, I should say modifying standard designs, because then we can make those apertures larger and have the structural loads what we need for for our station design. But again, that's a fairly straightforward engineering problem. And so the design and the construction of our rigid body habitation modules we are doing in-house. Let's see, and then, I should probably just mention Tim Clements, who's our a manufacturing expert on our team. He's built things much bigger and more complicated than this in his career. So this is a piece of cake. The hardest part at that point is just getting into orbit, and we're not doing that. We're going to contract with commercial launch providers. Okay, Alan, you got your hand raised. Why don't you go ahead and I'll unmute and you can ask a question.
Good morning. It's 6 a.m. here in Australia. So
what time is it in Australia right now, Alan?
6 a.m.
Well, thanks for joining the call. I appreciate it.
I've got two questions. Do you think the capital raise you're running right now will get you enough money to carry you through to launch of your demonstrator?
Yeah, that's a great question. No, I'll be perfectly frank. No, it's not getting us to launch. The point of the capital raise and the one we did earlier this year, there's two main objectives. One is allowing our supporters to get in early. We've had tremendous community support and a lot of public interest. And if you look at the space companies that are really making headlines today, the early days were closed to just a select few people. And so our whole mission of Orbital Assembly Corporation is making space accessible to everybody. And when I say everybody, I mean everybody of goodwill who wants to go and help make space a better place, right? And that starts with who can profit from what we're doing. So that's objective number one. The second piece is when we start to move towards institutional investors and investment bankers and all the big deep pockets, having a base of supporters and a track record of people who've invested really shows them that there is a market for what we're doing. And these first two raises have given us the runway, is the business term, the runway to be able to do the design and engineering that we need to do to get to the next steps, as well as the D-STAR program that we did earlier this year. All the design, the fabrication, and the assembly of that was all paid for out of pocket by the co-founders. The demonstration event, that was in part funded by part of the raise that was done earlier that year. So in a way, we were kind of giving back and making possible for the public to come see what we're doing, as opposed to just having it being a closed thing. And then those funds also have allowed us now to really dramatically accelerate the design, engineering, development of PSTAR gravity ring and the Pioneer station. And so this raise that we're in right now is giving us the ability to accelerate that engineering, get it to the point where we can go and start manufacturing. And if for the next part, when we go to investors, we can say, hey, we've got designs, they're engineered, they're ready to go. We're ready to build, and and then they can write us a check. It's not as simple as that, but that's basically the plan there. And then once we get Gravity Ring is going to have paying customers on it. We've already announced potential partnership. Well, I shouldn't say partnership. Leo Cloud is going to be flying hardware on the Gravity Ring, and we have some other clients and customers that are going to be flying hardware as well. And so the at that point we start to generate revenue, and then going into the Pioneer station, additional revenue from there. So my goal is to have us be cash flow positive and not require any additional capital investment from the time Pioneer station is operational moving forward. And we'll, if everything falls in line, then at that point we would be able to cash flow the construction of Voyager station, which I think is really exciting. Let's see, moving on. Justin says, is the assembly machine disengaged from the STAR once construction is complete, possibly to burn up in the atmosphere or get reloaded with materials to build another STAR, or does it remain attached permanently? So the PSTAR machine does detach from the gravity ring, and the PSTAR actually will be staying on orbit after it's finished building gravity ring to perform some other tasks, which I can't talk about yet, but we will be keeping it in orbit, and it'll be doing the next thing. Rajesh is asking, would you be able to highlight formal, informal partnerships you've been planning to use research resource from others to achieve the result fast? Sure. So we've made a couple of announcements. I think, like I just mentioned, Leo Cloud, who's doing distributed cloud computing services. They're one. I'm trying to think who we officially announced. I have to go back and look at our our documents. I had a lot of conversations with people lately. We are in talks. As I think I put out in the email earlier today, we're finalizing our negotiations for our launch provider. And I keep teasing that. I really want to make an announcement regarding that, but negotiations are negotiations, and that takes time. We also are really close to finalizing a deal with our environmental control and life support providers. So we'll be making an announcement about that shortly. And then one of our new advisors on our advisory board is Kai Stotts, and he works over at Biosphere 2 in Arizona, and he's got a Mars simulator, the SAM, that they've built there, and they're running simulations for environmental control and life support requirements in closed systems. And so we have a partnership, an informal partnership with them right now, where he's an advisor to us, and they're doing research, and we're able to collaborate and work back and forth on that. Trying to think who else I can talk about. Stay tuned. Oh, well, now I should say I think it was on the, it might have been on the pitch deck for the current raise, but with our NASA solicitation, we did get letters of interest and support from a wide variety of companies. So I can just maybe talk about that. So people who came out in support of our PSTAR, our Pioneer Station, included United Launch Alliance, Paragon Aerospace. There's probably like 24, and those are the two that jump into mind. But okay, we are running out of time here, but there's some really great questions, so I think we'll go a little bit over. Aiden, you have one more question? We'll get to you, and then I'll wrap up some questions in chat. Go ahead and unmute.
Yeah, I was going to ask, when Orbital Assembly is hiring people out of college, what degrees, qualifications, and experience are you looking for?
That is also, I can't talk and click at the same time. That's also a great question, Aiden. It really depends on what we're hiring for at the moment. So we're getting ready to, I think I can say this, we're getting ready to list some job positions for some senior level engineers. And for that, we're looking for people who have, specialties in certain engineering areas and years of experience. As we hire over this coming year, we'll be looking for entry level people as well. I think, so I've run businesses in the past, and I've hired, lots of people, and there's benefit to hiring people with experience, right? Having people who've been there, done that, know what they're doing, know the pitfalls, can get things done. But there's also a real benefit to hiring people who don't have any experience, who come out of college, they got fresh ideas, they know the basics, but they're kind of like a blank canvas with a lot of energy and enthusiasm. So I love to hire new people if we can have people who have the experience, who can shepherd and guide them and mentor them, then that's a really great combination, right? So I've said this before, and I'll say it again, I'm sure, do what you're passionate about, get jobs and internships anytime you can. Any experience is better than no experience. And, just be passionate about what you're doing. Alan, I do see your hand raised. I just want to answer a couple of these in chat real quick. See, YouTube for this broadcast will be available probably sometime tomorrow. And let's see. Oh yeah, Rogue Space. Now it's reminding me. Of course. How did I forget Rogue Space? Yeah, Rogue Space is one of our partners. They're actually probably one of the first. Appreciate that reminder. And John's asking about any current patents pending. And yes, we do. And we're preparing several more. And that will be something that really is ongoing as we're coming up with different things. Alan, I'll let you be our last question here, and then we'll wrap it up for today.
Thank you. I'm a very happy investor in the company. Thank you for that opportunity. And have you the ability to make use of a mechanical engineer like myself who lives in Australia in a freelance or some sort of mechanism where I'm not going to be traveling to America?
You don't want to come and visit us, huh? So yes, with conditions. One of the challenges with having foreign employees or contractors has to do with export controls and the way the U.S. government views foreign participation in space. And I don't necessarily see an issue with somebody from Australia or Canada or most of Western Europe assisting us. There's just a clearance process and a waiver process we have to go through. So, if your skills met a specific need that warranted us getting those approvals, I don't see that necessarily as being part of as being a insurmountable hurdle. That's also the same.
I'm semi-retired and will definitely pursue the opportunity with your company. And being semi-retired, I'm basically happy to work for an exciting company like yourself for free.
Oh, well, we always appreciate free work, but we do pay our contractors as well. Well, thanks so much, Alan, for that. And like I said, we should be making some announcements shortly about some of these engineering hires. And so just watch the emails and our website for that. So there's some really good questions still in chat, and I'm sorry we're running late on time. This is going to be published to YouTube later, so you can go back and watch anything you missed. And as Alan mentioned, our capital raise still is ongoing. If you want to have a chance to be a part of this, feel free to go to Net Capital and look us up and invest $100 or $1,000 or whatever you feel comfortable with. And we did just announce this week some gifts for our investors. And there's going to be an email going out early next week with a link so you can claim your gifts. We have our commemorative patch. We have a free T-shirt. We have a certificate. A lot of people have been asking for stock certificates. We don't issue stock certificates as part of the Net Capital process, but we have created a commemorative certificate that you can hang on your wall and show everybody, hey, I invested. And then the upper two gifts, you can actually get a one-on-one call with one of the senior members of our team. So if there's any questions you want to ask, you can have a one-on-one call with them. And then the final one, the higher tier there is we will actually engrave your name on the gravity ring. So you can have your name laser engraved, and we will fly your name to space with us on the gravity ring, which I think is really cool. I can't promise this, but I really want to be able to, I'll send you a picture of your name on the ring and possibly even send a picture of it in orbit. Right now, I can't promise that, but that's something I'm working for. I think definitely on the ground, I can take a picture of your name and email it to you. And then, hopefully we'll be able to get the cameras with our, drones and stuff to get a picture for you in space as well. But thanks so much again. And I think right now, the way the schedule works out is our next Friday with Tim will be on the 17th. And then we'll take a break until the new year because the one after that would be New Year's Eve. And nobody wants to show up for a call like this on New Year's Eve, right? So once again, I'm Tim. And thanks everybody for joining us. Have a great day.